Alright, so we're going to be looking at the margin of error, or MOE for short. And this has to do with our Evaluate Statistical Reports external. And just wanted to say we're going to use some examples, and these are from the June 2014 election poll from One News. So basically, margin of error, what is it? This is our uncertainty. This is the idea that we don't know exactly what's happening when we take a survey. We've got an idea, but we haven't asked everybody, so we don't really know what's going to happen. It's basically our sample error. So for the results of any poll, you'll always see that there's a lot of fine print underneath them, or if you hear it referred to on the radio, you're going to hear somebody say at the end, and the margin of error is plus or minus 5% or whatever it might be. So all this fine print, if you blow it up and actually read it, gives you some information. Here it tells us that we've got a random sample of 1,002 New Zealand voters, so we know they're over 18 and eligible to vote in New Zealand. And we've also found in here our margin of error, or as I sometimes say, a 95% confidence level, because that's what our margin of error gives us. Kind of like the bootstrapping in your external. You've got this interval where you're 95% sure that in the population that's where your number will actually end up. So if we take a look at our fine print and kind of try to interpret what this means, let's think about what we might say about it. So I paused that just so you wouldn't have to watch me writing at all. But if we think about this fine print again, this means we know that we've taken a sample. And this means there will be some sampling error, right? A sample does not tell us exactly what's happening in the population. So with a sample, we can never be absolutely certain that our results will be the exact same in the population. We have some uncertainty. And with the margin of error, we can say we are only 95% confident. So the margin of error helps give us, again, a confidence interval, much like you guys would have done in your internals, where we can say we think that the population is somewhere between these two numbers. So in this case, they've told us the margin of error is equal to plus or minus 3.1%. And there's calculations we'll learn about how to calculate this, and we use kind of a shortcut version of it. But this 3.1% means that our results of this sample could actually be 3.1% higher or 3.1% lower in the actual population. So again, that 3.1% tells us that our sample, or our survey in this case, results could actually be between 3.1% higher or 3.1% lower than the actual population. So if we take a look at some of these results, for instance, if we looked at national, using the margin of error, we're going to plus 3.1% onto that. So 50 plus 3.1 gives us 53.1%. And at the other end, 50 minus 3.1% is going to get us 46.9%. So really, we've got a confidence interval where this could have been anywhere between as low as 6.9% to 53.1%. And we're kind of 95% confident that the actual polling result for national is somewhere between that. So again, that's the 95% confidence interval that we would say we're 95% confident that the results for national are actually between 46.9 and 53.1% using that margin of error. So, although 50% sounds like the majority, would you be 100% confident that they actually do have the majority vote? And we would say no. We're not sure that they have the majority because, well, they could be actually below 50%. They could be below the majority that's needed, which is 50%. So they could actually have less than the majority, or potentially more than that. Again, we can't be uncertain, or we can't be 100% certain on it. So you have to be careful when you're listening to polls and reading them in the papers to remind yourself that, well, again, these numbers are approximations. They're just a sample, and it might actually not reflect what will really happen in an election or really happen if you took a census and asked everybody or had a vote and everyone could participate. And to kind of summarize this again, our margin of error looking here, our margin of error is how we say our sample is not perfect, but we are 95% confident that this confidence interval, using the margin of error, will include what's true in the population. So again, we're 95% confident that national is between 47% and 53% back in the population when they actually vote. And keep in mind that our margin of error accounts for sampling error only and not for the non-sampling error. So this accounts just for the fact that when you take a sample, you have some error because it's not the population. And here we're having to assume, the margin of error is going to assume that any poll or survey or anything like that was done with no non-sampling error. But we know that that's not always true. It might be how they asked or who they asked or anything like that. But again, the margin of error only is dealing with the sampling error, not the fact that they wrote leading questions or not the fact that they only asked people on the North Island, issues like that. Now there are some limitations to the margin of error rule that we're going to learn. And our rule of thumb, just to start with, is going to be 1 over the square root of n, and n is equal to the sample size. And we'll do some calculations as we carry on with this. But the limitations, to begin with, is that if you have a margin of error, if you have a percentage or proportion that's over under 30% or over 70%, it's not going to be as accurate. So again, this means we want something that's between 30% to 70%. Your rule of thumb, if we brave that rule of thumb, will be okay to use. And if it's outside of that, so less than 30 or over 70, your MOE is actually going to be a lot smaller than that. So these guys go together. So if you have a proportion that's outside of 30 or 70, the approximation here, this is an approximation rule, is not as accurate, and that's okay, but you just need to be aware of it. So for instance, our rule of thumb approximation is going to be quite good for national. It'll be pretty good for Labour. 29 is awfully close to 30%. But for the Greens or any of the other parties here, you'll notice that their percentages are so low, they're well below 30%, that the rule of thumb is actually not going to be that accurate for it. So we just need to be aware of that. It's the best approximation around 50% or around a proportion of 50%. And another thing to keep in mind for us is that the larger the sample size will give a smaller margin of error. And we remember that from our internal issues as well with bootstrapping. The bigger sample you take, or the more resampling that you do, the smaller confidence interval you'll get. So again, n is equal to the sample size. And if we have a big N, we'll get a big margin of error, or a little margin of error, and vice versa. So as an example, if I have a sample of 100, that gives me N equal to 100. My rule of thumb here for my margin of error, will be equal to 1 over the square root of 100. 1 over the square root of n. So that's equal to 1 over 10, which is equal to 0.1. And if we compare that, and we turn that to a percentage, so times by 100, you'll get 10%. So this is plus or minus 10%. And if we have a sample size of 1,000, that means our n is equal to 1,000. So you're going to have 1 over the square root of 1,000. If you plug that into your calculator, you get 0.031. And again, turning that into a percentage, times it by 100, you're going to get your plus or minus 3.1%. So again, big N, smaller margin of error, littler n, bigger margin of error. And the plus or minus, if you're confused by that at all, In words, that is just plus or minus. And that's again just saying that it could be 3.1% above or 3.1% below. And when you do your calculations, like we did as an example here, you do a minus and you do a plus, and you get those two different numbers. So be aware of the limitations for the margin of error. Again, this is only dealing with sampling error. It's best between 30 and 70% as a proportion, and the larger your sample size is, the smaller your margin of error will be.